Hey guys, in this lesson we're going to be talking about the square root property. Now the square root property is just one of the many methods that we have in order to solve a quadratic equation. We're going to begin by isolating the term that is squared using inverse operations. Then we're going to square root both sides of our equation, remembering that when we take the square root of any number we have both a positive and a negative root. And then we're going to simplify underneath the radical. One small note before we get started is that if we have the square root of a negative number, we can't actually take the square root of that number, so in that case we would have no real solution. Let's start with this first example. Here we have 64 minus a squared is equal to 0. We're going to begin by subtracting both sides by 64 so that we can begin to get the a squared by itself. So when we do that, we're left with negative a squared is equal to negative 64. Then our goal is to divide both sides by negative 1. And that would give me a squared is equal to 64. And now we can take the square root of both sides. Remember that when I take the square root of 64, it's going to be both 8 and negative 8, since there are two roots, a positive and a negative one. And then so my solution here would be positive or negative 8. We look at the next example. We have negative 3/4 y squared plus 5 is equal to negative 22. We're going to start by subtracting both sides by 5. This is going to give me negative 3/4 y squared is equal to negative 27. Our next step is going to be to multiply both sides by the reciprocal of our fraction. So in this case, our reciprocal of 3/4 would be negative 4/3. This is going to get rid of both the negative and the fraction on the left, leaving me with y squared is equal to, and we multiply negative 27 to negative 4/3. I know that I can cross simplify the negative 27 and the 3. Negative 27 becomes negative 9, and the 3 becomes a 1. So then that just leaves me multiplying negative 9 to negative 4, which would give me positive 36. I square root both sides. Remember that when I square root 36, it's both positive 6 and negative 6, so my solution here would be positive or negative 6, plus or minus 6. Now, the square root property comes in handy when we want to solve perfect square trinomials. So, if you don't know how to factor a perfect square trinomial, I encourage you to go back and watch the video for perfect square trinomials before continuing on with this one. So we're going to begin looking at this first example. Here we have c squared minus 4c plus 4 is equal to 16. First, we need to factor the perfect square trinomial. C squared minus 4c plus 4 factors to c minus 2 squared is equal to 16. Now we can take the square root of both sides. When I do that, I get c minus 2 is equal to 4, and I get c minus 2 is equal to negative 4. Remember, there's two roots to 16. When I add 2 on both sides, I'm going to get c is equal to 6, and I'm going to get c is equal to negative 2. And so those are my two solutions. Here we look at b. We have 25x squared minus 120x plus 144 is equal to 81. This perfect square trinomial factors to 5x minus 12 squared is equal to 81. Then we're going to square root both sides, and we get 5x minus 12 is equal to both 9, and 5x minus 12 is equal to negative 9. And so now I'm going to solve. So I get 5x is equal to 21 when I add 12 on both sides. I get x is equal to 21 over 5. Or, on the other side, I get 5x is equal to 3 when I add 12 on both sides. And then I get x is equal to 3/5 when I divide both sides by 5. And so my solution here would be 21 over 5 and 3/5. When we look at this next example, you're going to notice that the right side is not a perfect square. So it's going to look a little different. Let's begin by factoring the perfect square trinomial of x squared plus 12x plus 36. This is going to factor to x plus 6 squared is equal to 15. Then we take the square root of both sides. When I take the square root of both sides, I'm going to be left with x plus 6 is equal to 15, the square root of 15, and x plus 6 is equal to the negative square root of 15. I've subtract 6 on both sides. When I'm subtracting 6 on both sides, I'm going to actually write that in the front. So I'm going to be left with x is equal to negative 6 plus the square root of 15. We want the radical to be the last term in our expression there. And then we'll have x equals negative 6 minus the square root of 15 here. Now we can simplify the square root of 15. It's not a perfect square, so when we take the square root, we're actually going to have to round. When we take the square root of 15, it is approximately 3.9. So I'm going to have x is equal to negative 6 plus 3.9, and x is equal to negative 6 minus 3.9. And then when I simplify, I'm going to get x is equal to negative 2.1, and x is equal to negative 9.9. When we look at D, we have 4a squared minus 20a plus 25 is equal to 7. So again, let's factor the perfect square trinomial. This factors to 2a plus or minus 2a minus 5 squared is equal to 7. Square root both sides. I'm going to get 2a minus 5 is equal to the positive square root of 7. And I have 2a minus 5 is equal to the negative square root of 7. Now, when we're looking at this particular one, we're going to start by adding 5 on both sides. So here we're going to have 2a is equal to 5 plus the square root of 7. Then divide both sides by 2. And I'm going to get a is equal to 5 plus the square root of 7 over 2. And on this one, we would add 5 on both sides. This would give me 2a is equal to 5 minus the square root of 7. And then I divide both sides by 2, and I get a is equal to 5 minus the square root of 7 over 2. Now, if we wanted to simplify this, if we wanted to round it, I would actually probably start with taking the square root of 7, which in this case would be 2a minus 5 is equal to 2.6, and 2a minus 5 is equal to negative 2.6. And once I do that, then it makes it a little bit easier for me to solve on this case. So when I solve this one, I'm going to end up with a is equal to 3.8. And over here, I would end up with a is equal to 2.1 when we solve that equation. Let's move on to some application problems. So here it wants us to find the length of the side of a square with an area of 225 meters squared. So we know that the area of a square is a equals side squared. And we know that the area of the square is 225 is equal to s squared. So I can replace the a with the 225. And then we have a equation that we can solve using square root property. Square root both sides, I'm going to end up with s is equal to both 15 and s is equal to negative 15. But because we can't have negative lengths, my answer is just 15 meters is the length of my side. On the B, we have the radius of a circle is with an area of 125.6 yards. So they want us to find the radius here. So here I have a is equal to pi r squared. Again, if I know the area, I can replace it. So I have 125.6 is equal to pi times radius squared. If I divide both sides by pi, which we approximate to be 3.14, I'm going to end up with 40 is equal to r squared. And I can take the square root of both sides. I'm going to get r is equal to plus or minus the square root of 40, which could simplify to plus or minus 2 square roots of 10. Now I don't need the negative version here, so my answer would just be 2 root 10. And if I were to approximate this, I know that the square root of 10 is 3.2 approximately, and so my solution here would be 6.4 yards. When we look at these next two, we're gonna find the value of x for the square and the triangle. So here we're gonna start by doing 4x times 4x because we know that the area is 28. So here we'll have 4x times 4x is equal to 28, which is 16x squared is equal to 28. I can divide both sides by 16. This would give me x squared is equal to 28 over 16, which we could simplify to 7 over 4, and then take the square root of both sides. I'm going to get x is equal to the square root of 7 over the square root of 4, which is 2. And so we have plus or minus the square root of 7 over 2. Remember, we have positive and negative here. Again, one of the answers wouldn't make sense here since we cannot have a negative value for x. Our answer would just be x is equal to the square root of 7 over 2. When we look at B, we know that the area of a triangle is 1/2 base times height. And so in this case, that'd be 1/2 2x times 2x is equal to 46. I know that 2x times 2x is 4x squared. And so we have 1/2 times 4x squared is equal to 46, or just 2x squared is equal to 46. And then we divide both sides by 2. That gives me x squared is equal to 23. And so when we take the square root of both sides, we're going to be left with x is equal to plus or minus the square root of 23. In this case, again, we cannot have the negative root here, so it would just be x is equal to the square root of 23. This is how we solve problems using the square root property.